Rolf Gradinger. I'm from the University of Alaska in Fairbanks, and I'm studying the life here that is related to the sea ice cover in the Bering Sea.
Can you tell us a little bit about the ice that we're seeing?
Yeah, when you look around, the entire ocean surface is covered by sea ice, and there are all kinds of different forms of sea ice. When ice grows, it first starts as tiny ice crystals, and the older it gets, the thicker the ice is. So what we see here is older sea ice. That's probably a few weeks old, and it's so bright because there is a snow cover on top, and that snow cover is reflecting all the sunlight that we have. And that's very important from the biological perspective because it's so bright up here, that means that it's very dark in the water. So because of the sea ice, there's only a very little amount of light that reaches the water column below, and that means that it's very difficult for tiny plants to grow within the water at this time of the year. On the other side, there are little things that can grow within the sea ice, because the sea ice itself is porous. There are little pockets filled with a salty solution inside, and in these pockets we have hundreds and thousands of little plants and tiny animals crawling around in there, and that is my major research interest. So to figure out how many of these little things live with the sea ice and how relevant are they for the other organisms that live here in the Bering Sea.
So when we see the sea ice turn on its side and we see stripes and also the brown water, can you explain that a little bit?
Sure. There are two major reasons why you can have coloration of sea ice. The first one is a grayish, sometimes even black coloration that is sediment that is incorporated into the sea ice. So that has nothing to do with biology. What happens there is when the sea ice is forming, it's often very windy, you have storms, and sediment from the seafloor is resuspended in the water column, and part of that sediment is then trapped in the ice, and that makes the ice appear really dark gray or nearly black. So that has nothing to do with biology. The other coloration you can see every now and then is a brownish coloration right at the bottom of the sea ice, and that brownish coloration is completely due to the mass development of tiny plants. And these plants are really small. They are hundredths of an inch in length. And because they are so small, they fit in the ice crystals, but because they are very abundant, I mean, you have millions per square feet. Because they are so abundant, the ice appears brown.
Do you call those little animals little plants phytoplankton?
Well, if they would live in the water column below and they would be freely drifting in the water, we would call them phytoplankton. But while they are sitting in the sea ice, we call them sea ice algae.
Can they live for many years in the ice?
Well, not here in the Bering Sea, because in the Bering Sea ice exists only for a few months. So the Bering Sea itself is ice-free in summertime. So whatever life forms we find here within the ice, they must be capable of surviving the summer periods without sea ice. It's a different story if you go to the real high Arctic regions or north of Barrow. If you travel by a ship maybe 200, 300 miles north of the Alaskan coastline towards the North Pole, there you will find sea ice cover even in summertime. And there are actually real both plant species and animal species that live year-round within the sea ice and only occur with sea ice. This is what we call an endemic species that occur only within one habitat. Oh, I think it's a lifetime of research for me, future generations, and future generations. So whoever is interested in working on sea ice, its physics, its ecology, there are so many important questions right now to deal with that my guess is that for the next 100, 200 years people will still try to figure out all the basic functions of the sea ice in the Arctic ecosystem.